Hello everyone, welcome back to my channel. My name is Piyush. This is video number 8 in the series CK 2024, and in this particular video we'll be looking in deployments and replica sets. So from someone who's working on Kubernetes or someone who's preparing for CK, this is like one of the most important concept because everything that you do in Kubernetes, you do it to host your application as a container on the pod, and then pod has to be backed by a replica set, a stateful set, or a deployment. So this is one of the important concepts. That's what I said. I'm still having some sore throat, and my audio is gonna be a little harsh. I am still having this tea. I because I drink this daily before the recording so that I could record, I could speak. It has ginger, it has turmeric, like the raw turmeric, not the powdered one, and some honey, and it helps me with the recording. So yeah, thank you for showing the patience so far, and I hope you're having a good learning experience so far. If you think we are going too slow or if we are not covering all the topics, don't worry, we have a lot to cover. And the way I have planned it, we are moving ahead in this journey one step at a time. So I'm not overwhelming you with a lot of advanced concepts in the beginning. I'm going one step at a time, like baby steps. So don't worry about it. By the end of this playlist, I will make sure that you have all the required knowledge of CKA and Kubernetes fundamentals. So have some trust in me and please trust the process. It will make you a really good Kubernetes administrator at the end of this series. So just enjoy the learning and please follow along with me. Keep supporting me with your likes and comments. I would really appreciate if I could get 120 comments and 200 likes in next 24 hours for this video, and that's the target that we have set. So if we can get that, I will post another video in the next 24 hours. Thank you so much for your support. So let's begin with this video. Okay, so in last video we have seen how pod works, and this is the example that we took. In the last video we actually spun up a pod on a Kubernetes node and did some operations with it. Now let's take it one step forward. So let's say this user is accessing this particular pod. All right, I'll just make some changes to it quickly. Okay, so this user is accessing this particular pod. Like for now, just don't worry about it, like how the user is accessing it. Don't worry about that for now. Just imagine like there is a load balancer in between, or there is some endpoint that we have exposed externally, and we'll look at that in one of the later videos. But for now, just imagine that user is accessing this Nginx pod over some port, let's say port 3000, port 8080, or port 80. Okay, and something happened, right? And this particular pod crashes, right? This pod is no longer available. That means the user is not getting any response from the endpoint that it is hitting, like whichever way he's accessing it. Now, how do we make sure? Because this is one of the drawbacks of running the Docker container standalone. This is what we discussed as well. How do we make sure that user does not get an empty response even if the application crashes? There is some mechanism, right? There should be some mechanism because we are using an orchestration system. So it should have some mechanism through which it should be able to auto heal the application, or it should be able to spin up a new pod whenever the pod crashes, right? So yes, that's what we are looking at. We are looking at replication controller, which does the same thing for you. So what it will do, it will create a new pod for you as soon as this pod crashes, or even like it doesn't have to even crash. Sometimes for high availability, most of the times for high availability, we have multiple replicas of these pods running. So let's say we have this running, okay, and this is part of a object, another Kubernetes object, which is Replica Set or Replication Controller. Let's start with the Replication Controller first. So this over here is a Replication Controller. Okay, now if you remember when we looked at different controllers, because controller is something that is managed by controller manager. one of the Kubernetes component, which makes sure that your Kubernetes object or resource is up and running all the time. It is responsible for monitoring the resources. And there are different controllers, like we have a controller for node, for namespace, for pod, for everything, right? So this replication controller is to make sure that we have all the replicas running all the time, and it makes sure that application does not crashes even if there is a pod failure. So these two pods are now part of this replication set or replication controller. Now, there is also a difference between replication controller and replication set. We'll look that while we are doing the demo. So don't worry about it. For now, just think about what replication does. It spins up multiple identical instances of a pod, right? If we have one Nginx pod running, it'll spin up another one if we have specified two as the replicas. If we have specified 3 as the replicas, it will spin up another pod with the same image, right? So this is what it will do. It will have now 3 images, and these all 3 will be the part of your replication controller. Okay. I hope it is making some sense now. Okay. There is one more thing. So let's assume that it also makes sure your application is highly available all the time, because now we are not redirecting traffic to just one pod. We are redirecting traffic to replication controller. And then replication controller has the load balancing logic. Okay, this does not goes well over here. Okay, let me place this user where it belongs. Okay, so now these 3 application pods are running behind a replication controller, and this replication controller is responsible for redirecting the traffic to one of the active pods. So it has different mechanism through which it will check, okay, which pod is active or which pod is healthy, and it will redirect the traffic. Or there are some load balancing algorithm through which it finds the most healthy pods and so on. So this is what it will do. Now, like we have seen, even if one pod fail, let's say we have specified replicas as 3. Okay, so it will make sure that we always have 3 replicas running. We always have 3 instances of that pod running all the time. So if one fails, it spin ups one. If two fails, it spin ups 2 more pods, right? And let's say if replicas was 1, okay, instead of 3, let's say if replicas 1, what it will do? So yes, as soon as this particular pod fails, the one single instance fail, it spin ups a new pod, right? So it will make sure the application is highly available as per the replicas that we have set. So these number of replicas are the desired number of instances of that pod that is running all the time. Now, it also helps, like we have seen, it also helps with the load balancing. And for the increased demand, let's say earlier we have 3 pods, or earlier we had 2 pods, and the traffic on this particular endpoint or the application increases, right? So we need to have more endpoints, we need to have more applications to support the increased user traffic. So we spun up a new pod by updating the replicas from 2 to 3, and like we can increase it on a higher level as well. And let's say if it increased to the point where this particular node does not have enough resources, because pod, what it is doing, it is sharing the resources from the node itself, like CPU, memory, storage, everything is shared from the node itself. So let's say it reaches to a point where this node is running out of capacity. So in that case, what we can do is we can spin up a new node. So let's say we have spun up a new node over here. Okay. So this is another Kubernetes node. We spun it up and we provisioned a pod in the new node itself. Because this replication controller that you have used, it can span multiple nodes, right? So this is what we are doing now. So instead of redirecting traffic to 3 pods, now it will redirect the traffic to 4 pods, and the fourth one belong to a different node, and so on. So this is one of the manual auto scaling that we do. So in later videos, we'll look at the auto scaling, vertical auto scaling, horizontal auto scaling, and so on. There are a lot many concepts which takes care of this automatically. But for now, just understand how we do it manually by updating the replicas to the desired number of set, and then we can add more nodes as well. Okay, so I guess we are good with the theory part. We have some basic understanding of how replication controller works. Now let's jump into the demo and let's see how it works actually behind the scenes. All right, so inside our date folder, I'm going to create a new file. I'm going to call it rc.yaml for replication controller. Okay, so like any other Kubernetes manifest, any other Kubernetes object, it should have that top 4 properties at the top level. So API version, kind, metadata, and spec. Right. So API version for application controller v1. If you are not sure which version it is using, so kubectl explain rc for application controller. And if you go at the very top of this, it says version is v1, kind is replication controller with R capital and C capital. Okay. So 2 spaces, 1, 2. Okay. Now clear the screen and metadata. In metadata, you can add certain fields such as your name and labels. So hit enter, 2 spaces, and then name. Call it nginx-rc. And at the same level, at the level of name, because labels will also be part of metadata. So labels, enter, and inside labels, we can add multiple labels such as env demo. Okay. Now inside spec, now when we created pod, we provided certain specification of the pods, right? Like create this pod with this image, with this name, and expose that on this container pod and so on. Now we are creating a replication controller, which will in turn manage some pods. Whenever there is a pod that crashes or whenever a pod get deleted, it should spin up a new pod. But how did it know like which image to use for that pod, which version of the image to be used, what is the pod name, and on which port that pod should be exposed? So all that details will come from a template. So inside spec, we'll create a new field called template, and inside template we specify the metadata and spec of the pod. So if you remember our pod YAML, this one, right, we have these again 4 fields. So I'm gonna copy it from the line 3. Leave first 2 lines, API version and kind, we don't need that. And from metadata and spec, copy it. And then I'm gonna paste that in this section, in the template section. Okay, now paste it over here. Now it did not do the formatting and indentation correctly, right? So I'm gonna make this change. This over till here, it's fine, right? Template, we have spec. This is spec is of replica controller. Inside that we have template. Inside that we have metadata. And now this label should come inside metadata. So I'm just gonna select it. I'm gonna select the multi-line. In Mac, it is options plus shift. This is the VS Code shortcut. And if you are in Windows, I guess it is Alt and Shift. So I have selected multiple lines and I'm gonna press spaces 1, 2. So now labels it at the metadata. We need labels inside metadata. So 2 more. Okay. Now if you see this metadata and spec, these two are part of template. Right. So this is what we needed. Label is inside metadata and labels are inside the labels key value pair. Right. Now it is correct. We have 2 metadata. One is replication controller. Another one is inside the template, but this is for the pod. The same way we have 2 spec. One is for the replication controller. Another one is for the pod that is inside the template. So don't get confused between these two. So this section from here is all part of the pod template. We just copied from the pod YAML and placed it over here. So this is how it should work. Now it has one more field at the very last line at the level of template, right? Because everything goes inside that. Spec has children such as template and replicas. So over here, you specify how many replicas of the pod you want. So this is the desired number of pod that will always be up and running. So let's keep it 3. save. Okay, now I'm gonna apply these changes. So first, let me see if we have anything running. So we do have, so kubectl delete deploy nginx and deploy. Okay, now if we run get pods again, there is nothing. So kubectl apply -f and then rc.yaml. Says it's created kubectl get pods. We have 3 pods running. All 3 are part of this replication controller. So it created the pod with the name nginx-rc, which is the name of a replication controller, and then added a random number at the end. So if we do kubectl get rc, so this is the rc which has 3 desired pods. Currently we have 3 running pods and all 3 are ready, right? And if we want to check the specification of the replica controller or the pod, we can use kubectl describe pod, and then let's say this pod, hit enter, right? And it will show you that this is the name, this is the node on which this is running, and this is the label controlled by this replication controller. Okay, image id and so on, like all the details. And at the end it will show you the events as well. So if you face any errors, so errors will be logged over here as well. So this is replication controller. Okay, so we have seen replication controller. Now the difference between replication controller and replica set is replication controller is the legacy version and replica set, which we'll be using now. So replica set is the newer version. So this is the preferred way. If we have been given a choice, we will be using the replica sets over replication controller. The other difference is that replication controller will only be used to manage the resources, the pods that were created as part of that replica controller. But with replica set, we can manage the existing pods as well that were not part of this replica set. So we do that with the help of another field called selector. So use selector over here, and inside that, we do match labels. So we match the labels of the pods that we want to be part of this particular replica set. So inside match label, we use, let's say, the env demo, this label. So every pod that is running with this particular label will now be managed by the replica set. So this is the one, and now hit save. Let's change the name as well to rs, and then kubectl apply -f rc. Okay, it is throwing an error. It says no matches for kind replica sets in version 1. That means the version is not correct over here for the object replica set. So for that, kubectl explain rs for replica set. And if we go at the very top, it says the version is v1, but there is an additional field which is called group apps. So that means this version will be part of apps group. So the complete version will be apps/v1. So group/version. So that's how the version will be written. Now hit save and basically run the apply command again. And now it says created. kubectl get pods will show you the number of running pods. I guess we have, yeah, these 3 pods were already part of the replica controller. So I will be deleting that replication controller. So kubectl delete rc, and the name was nginx -rc. Okay, it says deleted. Now if we do get pods, we have 3 pods running. So these 3 are part of the replica set. Now this is the main difference between replication controller and replica set. The match label section at the very end. This is what it makes us different. Now clear the screen, and then we can now make our changes. Let's say we have to make our replicas from what we have 3 to 5. So there are several ways of doing that. One is, you update the manifest directly from here. Hit 5, save the file, and then apply the changes, kubectl apply -f rc. So now if we do get pods, you will see 5 pods are running and it made the changes instantly. That's one way. Another way, you can make the changes in the live object instead of updating the YAML. So kubectl edit and rs nginx -rs, right? So this is the live object. This is not the YAML, but the live object YAML. It will have a lot of other fields instead of what we have specified. So annotation, which will show you the last applied configuration. So earlier what we have applied, so we applied replicas as 5 earlier. So that is why it creates that in the memory and it creates an annotation for that. And it provides some other details like creation timestamp, resource version, UID, some metadata fields, right? So let's go to this section where it says spec. In spec, inside that there was replicas. So now I'm going to use Shift A. So Shift A is a VI editor shortcut to get the cursor at the end of the line and in the insert mode. So it is very helpful. It is very handy. So I try to use it very oftenly. So you can use that. Let's make the changes from version 5 to 4 and let's save the file. As soon as you save this, this will not ask you to apply the changes. It has already applied the changes on the live object. So now if you do get pods, you will see the four pods are running. So that's two way. The third way is to use the kubectl command, the imperative way, right? So kubectl scale -- replicas, and let's say 10, and then rs/nginx -rs. Okay, so this is the command, says it's scaled. Now, if we do get pods, we have now 10 pods running. So it made the changes. So try to use like a tip from the exam perspective, try to use the commands or the way that will help you save a lot of time. Like certain things, certain tasks can be achieved through various ways. And what we have seen is just one example. So try to use the one that will help you, saving you a lot of time, because in the exam, time is the essence. You will have a lot of labs, you will have a lot of tasks to complete, so make sure you save your time wherever you can, right? So for me, let's say if I already know the command, so running the command will be easier for me, or because we will not be having a VS Code editor on in the exam, right? If you are good with VI editor shortcuts and everything, so updating the live object will always be handy. And if you are not comfortable with either of those, you can always refer to the cheat sheet, the one that we saw, and all the options are there, all the commands are already there, so you can just copy paste. We have the option to get the commands from help, so you can do kubectl scale -help. And if you go at the beginning, you will see the sample command as well, kubectl scale. If the current replicas is 2, then make the replicas as 3, or you can make the changes like this, or the way that we have done like this. You can copy and paste the command from here as well. So whatever is helpful, whatever is helping you in saving a lot of time, you can use that. Okay, so that's all about replica set. Now we have to look another concept, which is deployment. I'm going to go over here. So this is what we already seen, replica sets. Now we have another concept which says deployment, and it provides some additional functionality to the replica set. So as a user, right, we will create a deployment. So we create a deployment. Okay, so as a user, we create the deployment, and then that deployments create the replica set, right? So these all pods and replica set, these all will be part of the deployment now. Deployment manages the replica set and replica set manages the pod. It will provide some additional functionality. So what is that? Let's say these pods are running version 1.1 of Nginx, because these all are identical pods. That means they will be running on the same version as they are part of the same template, right? And we have to make the changes. We have to update the version from 1.1 to 1.2. This is what we need. We need to roll out the changes basically. For that purpose, if we were running the replica set, it would apply the changes and it will recreate the pod all at once. And your user will face the downtime. Your active live users on the application will face the downtime for that brief period. For now, we are using a small application. It's just an Nginx application, and it's lightweight. It doesn't have a lot of things, so we might not get a lot of downtime. It takes just a couple of seconds to spin up the application, to start the container, and to keep it healthy. But consider this is a real-time production environment. Let's say a banking application or a financial institution, a stock trading application, where time is money, right? So you cannot afford a single millisecond of downtime in those applications. So how would you make sure that even though you are rolling out the changes, even though you are making the changes to the live environment, your users are not impacted? For that, you use deployment. What deployment will do, it will make the changes in a rolling update fashion. So it will update this particular pod over here, and while this pod is getting updated, the traffic is being served from these two pods, right? And it can also spin up a new pod to take care of the traffic that was part of this pod. So once this is up and running, it will add this to the load balancer or add this to the replica set, and start serving the traffic. The same way, when this version is undergoing changes, the traffic is being served from this pod and the last pod. And finally, this pod will be updated to version 1.2, and your deployment will be rolled out to your application entirely for all the users without any downtime. So this is the benefit that we get with deployment, and you can also roll back the changes to a particular revision, or you can undo the changes that have just been done. Right, so let's see how it works. So I'm in my Visual Code editor now. First, let's delete the replica set that we have just created. So rs nginx rs. Okay, it's been deleted. Now let's make the changes over here. Instead of replica set, now it is a deployment. API version is same. You can check it with the explain deployment command as well. Let's make it to deploy. And on the last as well, it's gonna be same. Let's change the replicas to 3. Okay, it's safe. Let's apply the changes. Apply -f rc YAML created. And if we do get pods, now we have 3 pods running, and these 3 pods are part of Nginx deployment. And if we do kubectl get deploy, so we have 1 deployment running with 3 pods out of these 3. All are healthy, all are up to date, and all are available. Now, if we do kubectl get all, so this command will return all the objects that are running in your cluster, all the Kubernetes resources. So get all. So it says it has 1 replica set with 3 desired, 3 current, 3 ready, 1 deployment with 3 out of 3 ready, 1 service. This is a default service that comes with your Kubernetes cluster, but we'll look into service in detail in the next video. And it also has 3 pods that are part of the deployment. So deployment created the replica set, which then created the pods. Okay, this is how it works. Now, if we have to make some changes, let's say we have to change the image, let's say from Nginx to Nginx 1.9.1. One way is through here to YAML, right? kubectl set image and image for deployment. So deploy slash nginx hyphen deploy. Let's use the multi-line command. So I'm going to use the backslash, hit enter. Now I'll just continue with my command. So kubectl set image deploy this. So change from nginx to nginx colon 1.9.1. Right, hit enter. Says the deployment is updated. So if we do kubectl, okay, let's do a describe deployment. So describe deploy dash nginx deploy. Okay, and if we go up to the section where it shows the image, so now image has been updated to 1.9.1. The image is not updated in the YAML, the local YAML. It's still the same, still nginx, because we changed the object, the live object on Kubernetes, right? Not on the local YAML file. So over here was the updated. Now we can check the rollout history with kubectl rollout history for deploy nginx-deploy. And it says there are two revisions. The one is the default revision when we created the object, and the second one is when we made the changes. So you can roll out the changes, you can roll back the changes as well. So kubectl rollout undo, this is the command, and then the name of the deployment. If we do that, now it should have created a newer version. So if we do the rollout history, it created a new revision. And now if we describe the deployment, you will see the changes has been rolled back. So we updated the image from Nginx latest to Nginx 1.9.1. And when we run rollout undo, it rolled back the changes and it made the changes to the image. And now it is Nginx latest again. So this is how you can roll out the changes. These all commands, again, as I said, you don't have to remember, but when you practice it, you will become habitual of remembering these commands. But this quick reference guide, this cheat sheet will be pretty handy in the exam as well as from, from practice point of view. All the commands that we have ran should be over here. So yeah, over here you see kubectl set image, rollout history, undo. You can roll out to a particular revision as well, and then rollout restart status and so on, right? So all the details are over here as well, and you can always run kubectl help. You can create the YAML from dry run. So if you remember it, let's say kubectl create deploy and then deploy nginx new. Okay, let's say if we dry run this, dry run equal to client, says required image is not set, so we need to set the image as well. Hyphen image is equal to nginx. Let's dry run it again, and it says it should be created. Now let's add hyphen o YAML to generate a YAML of it, and then redirect the YAML into a new file, deploy.yaml. Okay, there is a new file created, and if you see the content of it, has a kind, API version, label, it has spec. The default is one replica. It has selectors with matching labels and a few other default fields. And then it also has the container spec with image that we have specified. So you can generate the file like this, and then you can make the changes in your YAML. So do whatever is saving you a lot of time or whatever you are comfortable with. But there are multiple ways of doing things. There are multiple ways of doing these tasks. So yeah, these are all the things that I wanted to show you as part of deployment. All right, so that's it for this video, folks. I hope you now have a good understanding of replication controller, replica sets, and deployment, and you would have done all the hands-on by now. So there is a small, there are a few tasks that I have kept for you in the GitHub repository for day 8 folder. So try to complete that, try to do the hands-on, and it will be really helpful for you for the practice to understand this concept. And you won't be able to remember these concepts if you don't practice it. So make sure you do all the hands-on by yourself, even though you are following along with me with this video or any other video. So yeah, do that, and try to comment on the video, like on the video. Feel free to reach out if you need any help. We have an amazing Discord community where learners like yourself are there to help each other. So try to help each other. If you have any question, if you need any assistance, ask for help. Someone will help you. But if you don't have anything to ask, you can always go there and see what others are asking, and you can try to help them. This will help you increase your knowledge. This will help you make yourself a good learner. So thank you so much for watching the video as always, and gives this video a like and comment. Your support basically, that will keep me motivated, that will keep me encouraged, and I will keep producing content like this on a regular basis. Your support is required as always. So thank you for doing that till now, and I'm expecting you will always be supporting me like this. So thank you, and have a good day. I will see you soon with the next video.